In the next series of videos, we're going to look at how we can apply the knowledge that we have acquired so far of drawing multiple objects on screen, separating objects into classes so we can have multiple instances of them, and then we're going to start putting some conditionals into it so that we can keep track of what is happening and turn it into a fully featured state-based game system. So this is the early phase of it that we'll be working towards. For my example, I'm making a version of Duck Hunt. You can see where when I shoot the ducks, they just turn red and start falling. So they just have a simple color change. We could look at actually adding a state change and drawing a different artwork so it's even closer to the original arcade favorite and Nintendo favorite type of game. But right now, you can see when I move my cursor, the crosshairs are following it. I did set it up so we just have this kind of double barrel implied shotgun following the angle of the mouse. The ducks are all going right to left. The clouds are going left to right, which, because they have contrasting movements, it causes it to be visually a little bit more exciting. The clouds are class-based as well, so we have different instances of them randomly appearing, and then they animate themselves slowly across the stage. We can see how they're moving. And as you build your project, really what this comes down to is we're just working with simple objects. We can draw whatever we want. We can get as simple or complex as we want. So there's just a lot of opportunity for us to take this basic concept of coding and turn it into something that is both complex and entertaining. To begin our project, the first thing we're going to do is work with a little bit of our new content, which is making our object that is able to track the mouse. So to do that, I'm going to click on the arrow to create a new tab. This will be a class, and this will be the player. So class player. Again, begin with the capital letter. That is convention when creating a class. Then we'll have our properties. We'll have our constructor. And then the methods, the things that our class knows how to do. So under our properties here, we'll use float because then we can use fractional numbers, and x, y, width, and height. So you may see where this is going, that we have a lot of similarities to other visual objects that we work with. In the beginning, it's not a bad idea to fully type it out each time as you are trying to gain a handle on how everything works. And we'll just start it out in the middle of the screen. Y equals height divided by 2. And then our width here, I'm going to just set my width to 48, and my height I'll also set to 48. So you can do, on your projects, when you create them, I encourage you to change the numbers around, change colors around, change speed variables around, start to take ownership of it, make it something that fits with your concepts and your ideas. Then we have our standard 2 methods that it can do. So all of our visual objects usually follow the same process, that they have these 2 methods. So update, in this case we'll just say x is equal to the mouse x, and our y will be equal to our mouse y. So that updates the x and y position for this. And now I can just simply choose a color here. And the color that I'm going to go with is just going to be a transparent blue for now. So I'll say 0, 0, 255. And then for my alpha value, I'll go grab 50. So we can just grab the values that we're looking for, 0 to 255, and play with it that way. And then I'll say ellipse x, y with height. Okay, so now we've created the player. So let's add that up into our variables here. So again, that's when we create a class and instantiate it, we list that class there. Ints and floats and things like that, that's because those data types have been defined inside the language definitions itself. So P will now be equal to a new player. And then now that we have this, we have something to draw. So now we'll say draw. Fingers are being a little sloppy today. One thing I'm going to do now as this program is going to grow, we're going to put comments on our closing curlies and start getting in the habit of doing that. It's a good practice, so you know that anything related to draw needs to be inside, between the open draw line and the end statement. Anything related to setting up in our program needs to exist before end setup. So if we get in the habit of doing that, it's going to help you out when your code starts to get more and more complex. So now that we have that, run it, and we can see it's indeed working. Now what we don't have is we don't have a refresh. We're not clearing the background. So we can take care of that. Of course, we can just simply say background and choose the color that we want. I'm just going to go with this color here. And as always, your mileage will vary. Okay, so now we can see the circle is indeed following the mouse. Now the next thing that we need to do is we need to add some additional objects in for our player to interact with, and those will be the enemies. Then we'll figure out how to figure out when they are intersecting each other and come up with a plan of what we want to do, and that will be moving us into the next phase when we start figuring out what we want to have happen when they intersect. So once again, we will just create a new tab. This will be enemy, class enemy, curly brace, return twice, close curly. Now our props, constructor, methods. Do you have to put those comments in every time? No, but I would encourage you to do that because that is going to help set it in your mind of what you're doing when you create a class. All right, so with this we need our X, our Y, our width, our height, and a VX and a VY. Now, are we going to use all of those right now? Maybe, maybe not. Depends on how you figure out your movement and how you wish to set it up. We could possibly have a speed value that we're using to populate it. A lot of it will be kind of decisions that we will end up making as we develop how the interactions are going to take place. So now I have my enemy method. Actually, not end enemy, it'd be better to say constructor. No, it is named enemy because this is really our end enemy. That's the end of the class. And like the other one, void just update. Oh. And void display. So now it's primed to start planning some of these things out. Now, there's times when we position starting objects on or off screen, and when we're doing things like that, we usually are going to want to define our width values and height values first, because we may be referencing those in terms of where we place them. Nope, not as I was talking, so then Alright, our formatting will take care of it once we figure that out. That's a little better. And height here, or height, our visual representation of where we wish it to show up on screen. We can kind of figure out a random value on where we want it to be. So based on the size of my program, I'm going to just choose the random value. Now if we put in not one number but two numbers, we always need to start with the smaller of the two. So this kind of puts it somewhere between, knowing our project is 600 pixels tall, so it's going to be somewhere around appearing between 200 and 400, so right in that middle third. That's going to give us a position for it. So in our VX, in this case, I am going to set it equal to a random number. And if I'm going to replicate, moving right to left that I had on mine, we could choose something like -7 to -5. And our VY, for now, we're going to just set it to 0 so that it is just moving horizontally. We'll get into how to do arcing movements and things like that at a future point. So x plus equals Vx, y plus equals Vy. So now we have taken care of our update on it. We will have to check our boundaries for it in a moment, but then what I want to do next is actually draw it on screen and start to figure out how I want it to show up on screen. So if I want to choose a color for it. Now, two things. I want to choose a stroke color, so if I decide that I want to make yellow ducks, and that's going to be my fill color, I'm just going to put that in right now. And what I want to choose is a color before that, so I'll choose kind of a grayer but darker orange color. So I've now chosen that color. And we'll set our stroke weight, in this case, to 4, so it gets a little bit bigger around on the duck. Remembering that we draw from the center when we draw ellipses and circles. That's going to be important when we start to figure out collisions. Now, let's go over here and we'll first start out just with 1. And then we will make an array to hold multiple ones and use a for statement and all of that, or a for loop, all that fun stuff. But before I even start doing any of that, what I'd like to do is just to verify it, get it on screen and make sure it's working. Because keep it simple first. Start with it. Now when I look, we can see, oh. So I realize we've got a couple problems here. We need to do stroke, not fill, and paste in that other color. Now let's see what we got going. So now we got that, but we can see how that stroke color is continuing on to my player. So what that means is the player, we need to go stroke. And if I want the weight to be different on the player, I need to set a different value there as well. But if I just say stroke, and for the player, we're going to grab that color right there. So the colors, you can see now we have two colors. The player is going, but it disappears, or the enemy's going, but it disappears off screen. So we need to check our bounds. So for this particular entity, we have it set up right now so that if I go all the way to the left and off screen, I want to then go back to the other side. So if x, being x is in the middle of our duck, is less than 0, that means we're halfway off screen, plus our width divided by 2. Then at that point, we need, so let's just do a little and if, or get in the habit again of these closing things. So now if we've gone all the way off screen, then I'll set it back equal to x equal to width. Oh, and we probably should add into it plus width divided by 2. Otherwise we're appearing halfway on screen. So we should even do that here, plus our width divided by 2. So now if we watch, we should see our duck is going all the way off screen. Oh, it's not x plus, because notice it was disappearing too soon. We need to do x minus, so we can get less than 0. There we go. Now it's disappearing all the way off screen. So it's pretty common when we're doing these kinds of things is to get our pluses and minus flip-flopped on it. It's no big deal. We just need to pay attention to it. So I'm just going to add a couple extra returns in here so we have some white space, making it a little bit easier to read the code. And we probably could do end class right there. So again, putting those end comments in, it may seem obvious right now, but as your code grows in length and complexity, it is going to become that much more important. Now, we'll notice that the duck's on top of the player. I want to reverse that. So we're going to put the player on top of the duck. Now, yours may not be a duck. You may create whatever thing you want. Now we can see how it's on top and it's moving. Okay. So what we want to do is we want to figure out when these two objects are intersecting. So I've made a little sketch here to help demonstrate this. And remembering that circles draw from their center. So we have the green circle represents the enemy, the red circle represents the player. You can see the red one is following the mouse. We've got these two lines pointing at each other. So each circle is 100 pixels wide. The distance between their centers we can see, so the distance between the centers when we get closer to 100, right here, so 101, and then just when we drop under, we get this blue overlay showing us that when those two segments, the length of these two segments becomes essentially less than 100, so the sum of their radii. So what we're calculating is when the distance between their centers is greater than each of their half width, they're not intersecting. But when their half widths, which in this case are 100, when the distance between the centers are less than that, they have to be overlapping, or an intersection or collision has occurred. So we're going to take a look at how do we write that code? How do we make that happen in our project? And the cool part about it is it's a pretty straightforward little piece of code. So going back into our lecture file here, what we're going to do is make a function. Now this function, instead of returning void, is going to return a Boolean. So a Boolean is a value that is either true or false. So what we're going to do is when we run this function, it's going to give us back a statement and say true or false. True, they're intersecting. False, they are not. So we'll call it circle intersect. Now we have to tell it the kind of objects that we are examining. And I use A and B when I do this because I may make other variations of the same function. So I'll put it in my project, but I change, maybe it becomes player duck, and then it becomes projectile and duck. So if we start shooting at it and doing that, so we can just change the one word, the kind of thing it's looking for, and the rest of the code that we're going to write here is going to work. So what we're going to do is we're going to compare the distance of their centers to the sum of their half widths, or their radii, which is similar to how we do rectangle collision, except that the rectangles, because they draw from the top left corner, our math is a little bit different of how we figure it out, but the general concept is the same. So in my code here, let's make a value, and our value is going to be the sum of half widths. And we'll set that equal to a dot width divided by 2, well, having issues there, plus b dot width divided by 2. And then we will calculate how far apart their centers are. So the distance of centers will be equal to, and the cool part is processing has a built-in method, so we don't have to take 2 points and then do any trigonometry to calculate what is the actual distance between them. We can just go dist, short for distance, and we'll do a dot x, a dot y, b dot x, b dot y. It really is that easy to find that value. And then we'll say if our distance of centers is less than, meaning they will be overlapping, so if the distance of their centers is less than the sum of their half widths, return true, so it gives us back a true statement, else return false. So this way we're getting one of 2 possible values. So when we run this function, it's going to give us one of 2 possible values. Oh, and of course, yeah, I'm like, why do I have this red underlined line? This is player enemy. In my reference code, I just called it duck because I was imagining, it was a duck because I was building a duck hunt game. But we'll keep it more generic, so as you work on your project, you can make yours into whatever kind of critter you find interesting for you. So now what we can do is say if, oh no, not in our setup, in my draw here, if circle intersect, so we put these 2 things inside the parentheses here at the beginning because these are now parameters that we're passing into it. So when we call the circle intersect function, we pass to it the 2 items we're looking for. So then in this case we'll go P, comma, E, the 2 items that we're looking for. So if circle intersect is, and when we want to ask that question, we use 2 equal signs. We use a single equal sign when we're assigning a value. So if circle intersect is true, again, get in the habit of putting in those closing comments. So if that is true, and I'm just going to fill it with a transparent red overlay. Make it fairly transparent. Oh. I was, width and height, I just, in my brain, I short-circuited those. And that actually, I'm not drawing an object. I'm really, not fully on the game, apparently. But now if we run this program, let's see what we get. Now we can see, all right, let's make that red a little bit stronger. I mean, we saw it, but there we go. So we can see when it's overlapping, it's working. Okay, that's good. I mean, we'll figure out, when they do intersect, what we want to have happen. That will be in an upcoming lesson. So the final step we want in this beginning part is to make more enemies. So in this case, I'm going to change this. So instead of having a single enemy, I'll put in the square braces, and I will just call it enemies. Now, enemies, this is where we use our for loop. For int I. Actually, before we do that, we'll get a bunch of red stuff here because it's going to be grumpy. Enemies is equal to new enemy square bracket, and we have to figure out how many enemies we want to put into it. So we'll just start out and say 10. Well, there we go. There's my proper square bracket. So that's our number of enemies. So int I is equal to 0, semicolon. And then I, as long as that is less than enemies.length. And then I plus plus, because we'll iterate up on this. And 4. But E is not a new enemy, it's enemies square bracket I close square bracket. So now that populates, in this case we'll get our 10 enemies, all at different vertical positions. And now our enemies, when we're updating them, we'll update them inside a for loop, just like what we did here. So this time I'll try and type it correctly. For int I equals 0, semicolon, I is less than enemies.length, semicolon, I plus plus, close parenthesis, curly brace, return twice, close curly. So this is where what we want to do is we want to update, display, and also check for intersection. So we can take those and move them up here. Take this, move it up here. And now it's grumpy about these because it doesn't know what E is anymore. We don't have it. Instead, we're using enemies I. So now if I clean up my formatting, we can see there's no more red. So I can't auto-format until there's no more errors in your code. That's one of the things about processing, is it won't, if it detects an error, it will not format. So now we can see we have lots of them, and the more I run into it at any one time, because it's transparent red, the deeper everything becomes. We can also see there's some order issues here that it makes the background red, and because it does that, and then it draws some of the other ones later because they're happening later in the array. That's why they show up as yellow when we're doing this. What we could do is we could have a value, a flag, a Boolean flag, that'd be true false, to say, hey, is any intersect happening? And if so, so the circle intersect would just set the Boolean flag to true, and if it's not intersecting with anyone at the end of the run, then it can set it to false. So there's a couple of different ways we could go about it, but this is going to work for us because realistically you probably aren't going to have all of them running like this. And our intersect we're going to be switching it so it's not just when they're intersecting each other, but we're also going to have to say press the mouse, because if all we're doing is swiping across them, that's kind of a little bit too easy. But this is the first stage. We've got a bunch of enemies on screen, and when we're building our games, we don't really worry about making it, like finished artwork and super complex until we work out the functionality. So right now we want to just start getting our functionality in place and figuring out how that's working so we can start keeping track of score, or we can set up a timer so we don't release all of our enemies at the same time. So instead of seeing where they all drop off the side at once, we'll send out one, then the second, then the third. So we'll space things out. We're going to have a little bit more fun with it as we start to build this project. But for now, this is a small addition to the knowledge base you have, and you can just continue to grow from there. Good luck and have fun coding.